In section 5.3, we're going to be comparing linear and exponential functions. In the solve it problem at the top of page 301, in the blank space, I want you to write those two tables. Copy them down, and then I'm going to write directions, which you can or cannot write down. It doesn't matter to me if you write these down or not. The directions state to complete the table of values for the functions f of x equals 3x plus 2 and g of x equals 3 times 2 to the x power. We have a linear equation and a exponential equation or function. We want to find the differences and ratios of consecutive output values and then explain what you observe. Here's what you should notice. If we're looking at the differences of the output values for the linear function, look at this. Plus 3, plus 3, plus 3, plus 3. It's constant. But the output values for your exponential function doubles every time. It's basically times 2, times 2, times 2, times 2. But here's our ratio. What's the ratio of these two output values? 3, 6. 3 6 is 1/2. 6 12ths is 1/2. 12 24ths is 1/2. 24 48ths is 1/2. Therefore, the ratios of the output values of the exponential function are constant. These are all 1/2, or times 2 times 2 times 2 times 2. So here's what you should take from this. Linear functions are going to show that linear functions grow by equal differences. That means you add or subtract from one output to the next. But when you do exponential functions, you are going to be timesing by a common factor or by equal factors over each interval or each number. The first thing today that you're going to do is you're going to learn how to identify between linear and exponential functions. So in the got it problem, A and B, we want to identify are these linear or exponential functions. You look at your output values. If you have a table, look at your output values. We increase by 2. We increase by 2. We increase by 2. So because the difference is adding 2 every time, this is a linear function. This one, just by looking at it, you have an x as a power. Therefore, we already automatically know that this is an exponential function. So my two answers are linear and exponential. I want you to do number 1 on your own on the top of page 302. Pause the video and then hit play to see if you got it right. You should notice that every time the y value gets multiplied by 4. So since we're actually growing by an equal factor, we're multiplying by 4, it's going to be exponential. Problem 2. Identifying real-world linear and exponential functions. So here's the got it problem. The got it problem says, can you model the situation by a linear or an exponential function and explain? So part A says, Jack pays $30 each month. Well, $30 each month could be written as f of x or y equals $30 each month. That's it. It's linear. Why is it linear? Because every single month we're adding $30. So because every month we're adding 30, that's a plus 30 every month. It's a linear equation. Part B says, a culture starts with 1,200 bacteria. Every single day, the bacteria is halved. So we start with 1,200. Day 1 would be 600. Day 2 is 300. The next day is 150, and so on. What's happening every day? Every day you're dividing by 2, or you are multiplying by a half. Because there is a common ratio of 1/2, the situation represents an exponential function, because you are multiplying every number by a half. The next section is going to be investigating rates of change. So A says, How do the average rates of change for a linear function differ from the average rates of change for an exponential function? Well, the first thing I want you to look at is in the middle of the page there's a gray box. It says that the average rate of change of a function over the interval, basically x is between a and b inclusive, that means it includes a and b, is given by the average rate of change as f of b minus f of a over b minus a. So before we do part A, I want you in your book, wherever you see a blank area, I want you to write this down. So it says graph the function on the domain 0 is less than x is less than 6. Find the average rate of change of the function over the intervals 0 to 2, 2 to 4, and 4 to 6. Describe what you observe. Now, a lot of you are looking at this going, what in the world is this? I have no clue what I'm doing. Here's what it's telling you. Your domain is what you plug in. Remember, your domain is x. So you kind of have to do a t-table here. Your domain is x. The only values that you can use for your x value start at 0 and end at 6. Your x has to go from 0 to 6. So I'm just going to do 0, 1, 2, 3, 4, 5, 6. If you plug them all in, here's our equation. Our equation is going to be y equals 5x minus 2. So if I plug these all in, if you plug in 0, 5 times 0 minus 2 is negative 2. 5 times 1 minus 2 is 3, and then you just fill these in. These are all easy. So, graph it. So if you graph it, I'm going to go to 6. 1, 2, 3, 4, 5, 6. And I'm going to count by, I'll count by 5s. 5, 10, 15, 20, 25, 30. So if I graph these, 0, negative 2, 1, 3, 2, 8, 3, 13, 4, 18, 5, 23, 6, 28. Now notice your x values only go from 0 to 6, so we do not put it as 0. We do not put arrows on either side because we stop at the 0 and the 6. We start at the 0, stop at the 6. So here's the new part. Find the average rate of change. Your formula says this. F of b minus f of a divided by b minus a. So what it says, we have to find the average rates of change for every single interval that it says it lists at the top. So I'm going to start with interval 0 is less than x is less than 2. So what did you plug in? Here's what we plugged in. Now remember, we are plugging in your two values. So this right here, if you look at your book, again. Your book says A is less than or equal to X is less than or equal to B. That means the A is the 0, the B is the 2. So if I plug that into my equation, remember the A is the 0, I'm going to have F of 2 minus F of 0 over B minus A. B minus A would just be 2 minus 0. So F of 2, so you go to your chart. Well, what's 2 here? 2's here. This is F of 2. That's your Y value. So that would give me 8 minus F of 0 is right here. That's when you plug in 0, you get negative 2 for F of X. And then over 2, that gives you 10 divided by 2, which is 5. Now we do the same thing for the next interval. The next interval is 2 to 4. So we're going to do f of 4 minus f of 2 over 4 minus 2. F of 4, we look at our chart, f of 4 is 18, and f of 2 is 8. So it would be 18 minus 8 over 2. That gives me 10 over 2, which is 5. The last one, 4 to 6. So 6 is my b, so that'd be f of 6 minus f of 4 over 6 minus 4. F of 6, we look at our chart, is 28. F of 4 is 18. Simplify it, 10 divided by 2 equals 5. So what do we observe? The average rate of change is 5 over each interval. Therefore, the intervals are constant. The rate of change is constant. That is what we need to get out of it. The rate of change is constant. Now, if we actually did an exponential one, it would not be constant. An exponential would mean it'd be different every time. You'd actually get, if this was exponential, all of these would be different. And then so you could say after every increase or after every interval, it increases. So the rate of change is increasing. So if this goes up, the rate of change increases. If this goes down, the rate of change would decrease. So you need to tell me if the rate of change increases, decreases, or remains constant.